In this video, I'm gonna prove conditional probability, and I'm gonna show that always work in this correct at least. Conditional probability. Suppose I have n numbers from 1 to that until n numbers, consecutive numbers, n consecutive numbers, and we'll define A, the set of even numbers from 1 to m. I will define B as the set of m, the first m of the first m consecutive numbers, and I will prove that the probability of A, the picking an even, given that you are in the first m consecutive number, equals the probability of being even and at the same time being the first consecutive number and consecutive number divided by the probability of being on the first consecutive numbers. Now, the probability of A, given the fact that you are in B, is exactly out of the n consecutive numbers, the number of even. The number of even. Let me write it better. The number of even on the first n. On the first m numbers. I'm gonna call this x for simplicity. Okay, I'm gonna say x is the number of evens, even number from the first m consecutive numbers. I'm gonna write the probability of B is gonna be m, because it's the number of the number you have from 1 to m, divided by the total number of in the population. Oh no, begin B here is divided by m, sorry. If the probability of A, given that you are in B, you are already in B, you have only m numbers in B. It can be more than that. I'm gonna call x, which is gonna be x over m. X is the number of even until the number m. Now the probability of B is out of the whole population n, the first m numbers are the probability of B, and the probability of A and B is if A and B, that means it's gonna be x again, because you're gonna be the first, you have to be even and in B. That means you're gonna have the x again, and then the out of the whole, but this time out of the whole population. And now we're gonna do the math here based on the formula. Probability of A, I'm saying, I have a question mark here. Question mark. Probability of A, given that you are in B, question mark is probability of A and B divided by the probability of B. Let's see if this is true. The probability of A and B is x over over n divided by the probability of b by itself is going to be m over n, and this equal multiplied by the reciprocal to x over n times n over m. The n cancel, and we got x over m, which is the probability we have in the first place, the probability of a b. Now we prove that this is true all the time, because I did an example. It doesn't matter if they are consecutive or they are numbers or they are balls. This is a particular way of proving that the condition of probability formula is true. Also from here, we can say that the probability of A intersection B is the probability of B times the probability of A given that you are in B. We prove that at the same time. Thank you.